Welcome to our deep dive into experimental design and methodology. We're going to build a strong research proposal, piece by piece, just like a chain. This chain starts with finding a gap in what we know, which then leads right into your objectives. We'll see how this structured approach keeps your research focused and truly impactful. Let's jump into that first crucial link, your objectives. So what exactly are objectives in a research proposal? They're the specific, measurable steps you'll take to fill that knowledge gap you've identified. Remember, your objectives aren't just vague hopes, they're concrete actions. They tell us precisely what you aim to achieve, and they must directly connect to that initial gap. If your objectives don't clearly address the gap, your entire research chain has a weak link. Let's look at some real-world examples to make this clear. Here we see objectives in action, moving from a broad aim to a very specific step. Your primary objective is the big picture, what you ultimately want to accomplish. Then you break that down into secondary objectives, which are the detailed, achievable tasks needed to reach your primary goal. For instance, if your primary objective is to optimize antigen retrieval, a secondary objective might be to compare citrate versus EDTA buffers. This structured approach ensures every part of your research contributes to solving the main problem. Now let's see how these objectives lead us to our research question or hypothesis. Let's clarify the difference between a research question and a hypothesis, a crucial link in our chain. A research question is simply an inquiry, something you want to find out. A hypothesis, on the other hand, is a testable statement, a proposed answer to your question that you'll then try to prove or disprove. The key here is that a hypothesis is always testable and falsifiable, meaning you can design an experiment to show it's wrong. This distinction is vital for designing your experiments effectively. Let's see how these play out with some concrete examples. Here we see how a research question or hypothesis directly follows from your objectives. For example, if your objective is to determine the optimal pH for antigen retrieval, your question might be, what is the optimal pH for antigen retrieval in formalin-fixed tissue? Your hypothesis would then be a specific prediction, like a pH of 9.0 EDTA buffer will yield the strongest antigen retrieval signal for Ki67. This high pH EDTA works by chelating calcium ions, forcefully breaking those formalin crosslinks. Now, notice how the hypothesis is a direct, testable statement. This clarity is essential for designing your methodology, which is our next link. Now we move to the third link in our chain, which is the approach or methodology. This is where you detail exactly how you'll answer your research question, turning your hypothesis into a concrete plan. Remember, your methodology must directly address the question you just posed, making it the practical blueprint for your investigation. We're building this proposal like a chain, and each link needs to be strong and connected. For instance, if you're debating between citrate pH 6 and EDTA pH 9 for antigen retrieval, your methodology needs to clearly state which you'll use and why. EDTA at pH 9 is highly aggressive, fantastic for strong nuclear antigens like Ki67, but it can risk tissue detachment. Citrate at pH 6 is gentler, safer for tissue, but might understain some targets. Your approach needs to justify that choice. We're building this proposal like a chain, and again, each link needs to be strong and connected. Now let's look at the specific elements that make up a robust approach. So what are the key elements of a strong approach? First, you need to identify your variables. What are you measuring or manipulating? Second, You'll describe your methods, including the specific techniques and materials you'll use. Finally, you'll outline your procedures step by step. These elements ensure your approach is clear and reproducible. This slide breaks down the core components you need to consider for your methodology. For example, if your hypothesis is that high pH EDTA works by chelating calcium ions to break formalin crosslinks, your method section would detail the specific EDTA concentration, pH, and heating parameters you'd use to achieve that chelation. These elements ensure your approach is clear and reproducible. Now, let's see how this approach looks when put into action. Let's see this approach in action with a histotechnology example. If your question is about the optimal pH for antigen retrieval, your approach would detail the specific pH values you'll test. You'd also specify the type of tissue, the antibody, and the detection system. This example shows how a clear question leads directly to a focused methodology. This is where we take those abstract ideas and make them concrete. For instance, if you're testing different pH levels, you must only change the pH. Imagine a lab nightmare where a tech changes the buffer and increases the primary antibody incubation time, gets a dark stain, and has no idea which change actually worked. That's a waste of time and expensive reagents. This example shows how a clear question leads directly to a focused methodology. We're taking those abstract ideas and making them concrete. Next, we'll talk about making sure everything lines up. The most important rule for your approach is that it must line up perfectly with your research question. If your question asks about pH, your method must vary pH. You can only change one variable at a time to get meaningful results. This alignment is critical for a sound proposal. This is where we ensure everything is consistent and logical. For example, when analyzing your slides, the operator should be blinded to which slide received which treatment. If the operator knows which slide is EDTA treated, they might subconsciously set the detection threshold lower to help the hypothesis succeed, introducing bias. This alignment is critical for a sound proposal. This is where we ensure everything is consistent and logical. We'll discuss fixing misalignments next. We're talking about fixing misalignments now, and this is where your proposal really starts to take shape. Think of your research as a carefully constructed chain, as we've mentioned, again, where every single link must connect perfectly. You start by identifying a clear gap in the literature, then your objectives address that gap, which leads to your research question, and finally your methodology. Again, for example, the debate between citrate pH 6 and EDTA pH 9 for antigen retrieval is a classic misalignment point in the lab. EDTA at pH 9 is aggressive, but great for nuclear antigens like Ki67, and it also risks tissue detachment. Citrate at pH 6 is gentler, but might understain. Your proposal isn't about results yet. It's about a solid, aligned plan. This careful alignment ensures your entire study is coherent and defensible. Now let's dive into the core of your paper. The crucial difference between a research question and a hypothesis. A research question explores an unknown, like, what is the effect of X on Y? But a hypothesis makes a testable prediction, such as increasing X will lead to an increase in Y. Remember, the golden rule of experimental design is to change only one variable at a time. Again, imagine a tech changing the buffer and increasing primary antibody incubation. They get a dark stain, but don't know why. Again, wasting time and wasting expensive reagents. A high pH EDTA works by chelating calcium ions, forcefully breaking formalin crosslinks. This is the kind of specific mechanism your hypothesis should address. This rigor ensures your conclusions are clear and directly attributable to your intervention. To wrap things up, remember that my feedback on your outline is one of the most valuable you'll get all term. It directly shapes your final paper, so take it seriously. If you build this outline well, your paper is already half written, and you'll feel that difference next week when you start drafting. For instance, in image analysis, having a blinded operator is crucial. If they know which slide is EDTA, they might subconsciously set the detection threshold lower, which helps the hypothesis. This kind of bias is what a well-structured plan helps you avoid. So put in the effort now, and you'll thank yourself later.